Welcome everyone. In this video, I'll show you how to solve an energetics question using a Hess cycle. It's an A-level chemistry exam question. Details are in the description. Let's get started. Here's the question. Potassium chlorate 7, KClO4, is used in fireworks. When potassium chlorate 7 decomposes, it produces potassium chloride and oxygen. Give an equation for the decomposition of potassium chlorate 7. Use the data in the table to calculate the enthalpy change for this reaction. I've edited the question here, leaving only the essential information. Let's start off with the equation for the decomposition. KClO4 is a reactant on the left and decomposes to form KCl and oxygen. Oxygen exists as molecules of O2. To balance the equation, 1 mole of KClO4 will produce 1 mole of KCl and 2 moles of O2. For the second mark, we have to calculate the enthalpy change for this reaction. We are given standard enthalpy of formation data in the table. Standard enthalpy of formation, delta FH, is defined as the enthalpy change when 1 mole of a substance is formed from its constituent elements in their standard states. You should try to memorize this definition as well as the other standard enthalpy change definitions in this topic. You could be asked to give them in the exam. I've constructed a Hess cycle here. I could balance this with the chemical symbols for the elements in their standard states at the bottom, but to save time I've just written the word elements. In this case there are no extra marks available for a balanced Hess cycle. Next, I've labelled the enthalpy changes. Delta RH is the enthalpy change for the decomposition reaction. Delta 1H shows that 1 mole of KClO4 has been formed from its constituent elements, so this is equal to the standard enthalpy of formation of KClO4. The value for this enthalpy change is given in the table, minus 434 kilojoules per mole. Delta 2H is equal to the standard enthalpy of formation of KCl. The value for this enthalpy change is given in the table also, minus 436 kilojoules per mole. Delta 2H also includes the standard enthalpy of formation of oxygen, but think about the definition. 1 mole of O2 gas will be formed from 1 mole of O2 gas. The enthalpy of formation of any element in its standard state is 0. To find the enthalpy change for the reaction, delta RH, we can apply Hess's law. Enthalpy change is independent of the route taken. We also need to know that enthalpy changes are vectors. They have magnitude and direction. One route for the enthalpy change that we need to find follows the green arrow. We start at KClO4 and end at KCl and 2O2. This is delta RH. An alternate route involves going from KClO4 to elements following the blue arrow. This is going against the direction of delta 1H. This part of the alternate route is equal to minus delta 1H. To complete the alternate route and then at KCl and 2O2, we follow delta 2H going with the arrow. Using Hess's law, delta RH is equal to minus delta 1H plus delta 2H. To complete the question, substitute the values into the equation. Take care with directed numbers. Many students make mistakes when subtracting negative numbers. The final answer works out to be minus 2 kilojoules per mole. One final thought. You may be thinking that this is a lot of work for a 2-mark question, so do you really need to use a Hess cycle? The short answer is no. But if you know how to construct Hess cycles, you are more likely to get most of the questions on this topic correct, and it will really help with Year 2 thermodynamics. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your exams.